Good evening, Namaste, Hare Krishna. How are you? How are you doing? Nice. In the previous class, our last topic was how to find more rational numbers between two given rational numbers. I told you there are various methods, but I taught only one yesterday. Let us discuss about them, about two more methods today. And before that, I would like to tell you about the schedule we will be following from the next week. Our classes will be from Monday to Friday, and we will do 3 days maths and 2 days science. Out of which we'll do MWF maths and Tuesday, Thursday science. Is that okay?
Yes, sir.
Okay, since this was the starting in this week and the schedule was not ready, not determined, so we did all 3 classes, 4 classes, only maths. So next week onwards we'll be following this. Today we will be doing maths only, and Friday it is. Finding more rational numbers between two given rational numbers. Two given rational numbers. So on the path of this, I'm introducing one more thing here, midpoint formula. Midpoint formula. On the number line, here we have, suppose, two numbers 2 and 3. Can you guess what is the exactly mid number between 2 and 3?
2.5.
2.5? Sure?
Yes.
That's good. So let us see how do we find it mathematically. We could guess it easily. It was easy to guess.
Yes, sir.
Because those numbers were very close to each other. They were continuous whole numbers, natural numbers. The formula is you add the two numbers and the sum is divided by 2. First number 2, second number 3, you add them and divide by 2. You get that number just in the mid. That's it.
Yes.
We will use this formula to find more rational numbers between two given rational numbers. So think of two rational numbers. Randomly I am taking 1 by 2 and 3 by 4. And I want to find as many as we can, but I am taking 3. So I am creating a question here. Find 3 rational numbers between 1 by 2 and 3 by 4. So just using the midpoint formula, let us find the midpoint between them. Let us say point A is 1/2, point B represents 3/4, point C is the midpoint, point C is, add the two rational numbers given 1/2 and 3/4 and divide it by 2. This is midpoint formula. A different style may be there for division by 2. Let us write it in a different way. I will add the 2 and divide by 2. It can be shown this way as well. I hope this is not a problem for you. That's the same thing, na? We have added the two rational numbers and divided by 2. That's the same thing. Just writing style is different. Now 1/2. And I told you how to add the two rational numbers in short manner. Denominator multiply, 4 to the 8.
Multiply.
You can take LCM also, that is also a way.
Yes.
But I think this way we can do it in short, briefly, quickly. 4 to the 8 in denominator and then cross multiply. 4 1 ja 4, 2 3 ja 6, 8 plus 4, 8 plus 6, 14. Now cancel out wherever possible, 2 7 ja. So we get 7/8. That's the mid number we got. So first rational number we got between them,
7/8.
correct?
Yes, sir.
Okay. Now let us find the mid number between A and C. Let us name it as D. Mid number of A and C. Point D. Again we will do the same practice. We will add 1/2 and C, that is 7/8. 1/2 and 7/8. And we have to divide the sum by 2. So do this. Now let us simplify. 1/2 into 8 to the 16
16.
and 8 1 ja 8, 2 7 ja 14. So 8 plus 14, 22.
Yes, sir.
2 11 ja 22. So we got here 11/16. Here.
Yes.
One more rational number we got here between 1/2 and 3/4. And we need one more because total 3 is required. So let us take this time midpoint between C and B. Let us name it point E. Point E. For that, which two rational numbers we will add? Guess?
7/8 and 3/4.
Exactly. 7/8 and 3/4. And we have to divide it by 2. So multiply with 1/2. That's the same thing. Dividing by 2 or multiplying with 1/2. They are same, right?
Yes, sir.
Yeah, this is what I am doing. 1/2 times 8 4 ja. You can take LCM, whichever you think is easier. Now since the number is getting bigger and bigger, so let's take LCM this time. This time I am taking LCM. 8 is LCM. I am writing LCM 8. 7 plus 6, 13. Is that right?
Yes, sir.
Because 4 2 ja 8 and 2 3 ja 6 here. So 7 plus 6, 13.
Yes, sir.
And the cancellation is not possible. So 13/16. We got the third one as well. 13/16.
Yes, sir.
We got all three rational numbers between 1/2 and 3/4 using midpoint formula. Our answers are done. Hence, 3 rational numbers are 7/8. Let's write from the smallest one. Smallest is 11/16, then 7/8, and the largest one 13/16. The smallest because it is on the very leftmost. 11/16 is the leftmost, and 13/16 is the rightmost. That's why 13 by 16 is the largest, 11 by 16 is the smallest. So in the ascending order I wrote it. I hope that's not a problem now, understanding?
No, sir. Yes, sir.
Okay. Now we will do the same question in one more method. One method was already discussed in the previous class. This was our second method.
Yes.
Now we are going to do the third method. What to do for that? We convert both rational numbers into the decimal form. The first one is 1 by 2, that is equal to 0.5.
0.5.
The another one is 3 by 4. It is equal to 0.75, right? Correct?
Yes.
You can divide it if you are not comfortable. You can divide 3 by 4 like this. 3 by 4. 3 is smaller than 4. So before we move ahead, we have to take a decimal here.
Yes.
And in turn, we have to take a 0 in this place. Now 4 7 ja 28. 2 is the remainder. Now we take one more 0 for that decimal. 4 5 ja. So 5 here and the 20 got cancelled, remainder 0 this time. So 0.75.
Yes.
First one is 0.5, we can put a 0 here. So 0.50, 0.75. Now notice the given rational numbers are 0.50 and 0.75. And we need more rational numbers between them. So now it is very easy to find. We can find as many as we want. But since we need only 3, so let's randomly write. Hence, 3 rational numbers between 0.50 and 0.75. Can you guess the first one? Just try to make the first one. More than 5?
0.5.
0.5 is the border.
0.5.
5, 1.
0.5.
That's correct. 0.51, 0.52, 0.53, that way, right?
Yes.
Okay. 0.52, 0.53, as many as we want, we can take. But presently we need only 3. Done. It could be 0.6, 0.61, 0.62. It could be 0.7 as well. 0.7 also is before on the left side of this. So 0.7, 0.71, 0.72, 0.73 are all between them. So this was the third method. I hope you found it easiest one.
Yes.
Right. So total 3 methods to find more rational numbers between the two. So whichever you prefer, whichever you think is comfortable for you, you can do in exams. But what actually happens, reality is there. In exams, if your teacher is asking the same question, the teacher may be having a motto, an aim to check your knowledge to find rational numbers in this form, P by Q form, this way, this way, this way, not in the decimal form. I'm just telling you general idea. I'm not telling you that's a rule. Some other teacher may not be bothered about that. Some teacher may be okay with each of them, but some teachers may be only expecting this type of answers.
Yes.
So if you choose one of the first and second methods, that would be better idea for exams. Third idea is also okay. Keep it as knowledge. Done? Good. Just a moment. The next thing is I taught about the decimal representations, right? 3 types of decimal representations. Do you remember? 3 types of decimal representations. I taught this.
Yes.
Like terminating, non-terminating. Do you remember?
Non-terminating.
Okay. So all 3 were done. Okay. Now the next topic is converting non-terminating, or let's write converting decimal representation to P by Q form. Now this is our topic. A number, when it is given in decimal representation using decimal dot sign, we have to convert it into P by Q form, and we know decimal numbers are of 3 types. First type, terminating decimal; second type, non-terminating repeating; and the third type, non-terminating non-repeating. Perfect. So one by one we will talk about each of them. We can do them or not, how to do, etc. So let's take the first type, case 1, terminating decimals. Terminating decimals. 0.23. Are you comfortable changing it into P by Q form? Samira, would you like to try?
Pardon, sir?
Would you like to try to change it into P by Q form?
Yes, sir.
No? And Ahana?
Yes, sir, I can.
Would you like to try?
Yes.
Okay, try this. I'm waiting for your reply.
23 upon 100.
Perfect. Perfect. You did
23
it.
upon 100.
Exactly, exactly. Correct. Well done. So what's the method? Simply replace the decimal and write 1 in the denominator. Replace the decimal, remove the decimal, put 1 in the denominator. Then count how many digits are there after decimal. Put as many zeros as the digits are there after decimal.
Yes.
Is that okay? Let's record it here. Method. Remove decimal. Remove decimal and put 1 in denominator. This was the first step. Number 2, put as many zeros as the number of digits on the right side of decimal. That's the method. Let's try one more. Would you like this time, Samaira?
Yes, sir.
2.13. Try this.
Mm, 1300.
Once again. See, remove decimal, and put 1 in the denominator. I removed the decimal, and what remains after removing decimal? What do we have after removing decimal? 213. That will go to the numerator. We have removed decimal, put 1 in the denominator. First step done. Second step says put as many zeros as the number of digits on the right side of decimal. On the right side of decimal we have 2 digits. So we have to put 2 zeros here. Done. Is that okay?
Yes, sir.
Try one more. This one.
43 upon
Upon what?
43 upon 100.
Correct.
43 by 100.
Perfect. One more. This one.
6 by 10.
Correct. We can simplify as well whenever possible.
Yes, sir. 3 by 5.
Like, yes, 2, it's 3 by 5 actually. By 2 we can cancel. 2 3 jar, 2 5 jar, 3 by 5. So this was about terminating decimal. We have discussed how to change terminating decimal into P by Q form. Let us now go to second case.
Yes, sir.
Case 2. Non-terminating repeating decimals. Non-terminating repeating decimals. For example, 0.35 bar. Do you know how to change it into P by Q form? No? Okay. While not talking, you can keep the mic off. So I'm going to teach how to change this non-terminating and repeating decimal into P by Q form. Be focused. This means 0.35355 and so on. Sorry to say, there is some disturbance on my side. You might be experiencing some noise pollution from my side. In my neighborhood, some persons are
sir,
celebrating. Yeah, they are actually celebrating some family functions are there. So if you can tolerate, we can continue. It's okay? Can we continue? Your voice is not coming. Samira, Ahana, can we continue?
Yes, sir, you're not. Yes.
Okay. So 0.35 bar sign means 0.35, 35, 35 and so on. So let x is equal to 0.35, 35, 35 and so on. Now what you need to do is multiply this equation. This is now an equation. Consider this as our equation 1 and multiply both sides of the equation with what? With
10.
10 can be taken, but better is to take 100. Why so? Because we have bar sign over 2 digits. Bar sign over 2 digits. So let's multiply both sides with 100. Is that okay?
Yes, sir.
So left side we have 100x. On the right side we have 35.35, 35, 35 and so on.
Yes.
Notice what happened. Complete one chunk came here on the left side of decimal and the remaining things are exactly same on the right side. Did you notice? And this is what we will get advantage of. This is our second equation. We will subtract 1 from 2. Second equation is 100x is equal to 35 decimal 35, 35, 35 and so on. Equation 1 below it, x is equal to 0.353535 and so on. And notice this writing style is important. You have to put the decimal just below the decimal.
Yes, sir.
Now notice all the digits are exactly same. If we subtract, what we will get? If we subtract, on the left side it is
99.
100x minus x, 99x. On the right side 35 minus 0 is 35. And after decimal we are getting 3 minus 3, 5 minus 5, etc. Actually all of them becomes 0.
Yes.
Just 35. So x is going to be 35
Upon 99.
upon 99. Done. Answer. P by Q form. Any questions?
No, sir. So what if the bar sign is only on one digit?
Only one digit. Let's take an example of that type.
Only.
Change 0.3 bar into P by Q form. So first of all, we will assume
Sir, no, not like that. Like 0.35 bar only on 5.
Okay. This, right?
Yes, sir.
Okay. 0.3555 and so on. This is our first equation. This time,
Yes, sir.
if you multiply with 10, that will also be okay. Only one digit is having bar sign, so multiply with 10 at least, that is okay. This will work. If you multiply with 100, that will again work, no problem. Only one digit has bar sign, just 10. Let us do it. So left side we get 10x, right side, if we multiply with 10, one digit will come on the left side of decimal, so it is 3
Yes.
decimal 5 5 5 5 and so on. This is our second equation. Subtract 1 first equation from second equation. Second equation on top, and first equation below it, making an arrangement, x term below x term, equal below equal sign, decimal below decimal, 0 on the left side of decimal, and then 3 5 5 5, 3 5 5 5 and so on.
Yes.
Now subtract 10x minus x is 9x, equal sign, and notice after this everything will be 0, right?
Yes.
5 minus 5, 5 minus 5, everything 0, but we will get one digit after decimal here. Are you writing?
Yes.
Ahana?
Ye-
Don't write it now, because I'll be sending this PDF. You can write it later also. Focus on understanding, okay? Good. 3 minus 0 is 3, decimal 5 minus 3 is 2. So we got 9x is equal to 3.2, x is equal to 3.2 divided by 9,
By 9.
and now we have to remove the decimal from top. How to?
Yes. Yes. 32 by 90.
Perfect. Actually 3.2 means 32 by 10. For decimal we
Yes.
put 1 and 10 for one digit, so by 10.
Yes.
But 9 is already there in the denominator. If we write 9 in the denominator, it will be 90. So 32 by 90.
Yes.
Done. P by Q. If simplification is possible, we will simplify, else leave it. Presently possible to simplify. 2 16 ja, 2 45 ja. So 16 by 45 is the answer. Now if you want to check if we have got the correct answer, we can use calculator for cross checking purpose, or we can just do the long division to divide 16 by 45. I am going to cross check it with the help of calculator.
Okay, sir.
16 divided by 45. See here, 16 divided by 45 equal 0.355555.
Yes.
So verified, answer is verified. Any more questions?
No, sir.
So you need to remember the number of digits having bar sign over will give us the number of zeros we have to multiply with. If there are 2 digits with bar sign, we will multiply with 100. If there are 3 digits with bar sign, we'll multiply with 1000.
1000.
It's not hard and fast rule, let me tell you clearly. It's not a hard and fast. I'm suggesting you 1000 for 3 digits of bar. But maybe it will sometimes work with only 100. Possible. It's possible. I'm not telling it's hard and fast rule, but I'm giving you a safe zone. You can feel it at a safe zone. But yes, there is another aspect. A student always should be like a researcher, explorer. Be an explorer as well. Whatever I'm teaching here, it's just basic things. You are learning from me some basic things. Now you can explore for more knowledge. You can try sometimes doing the same question, multiplying with 100, multiplying with 1000. Do these type of researches. If you want really learning, you should be an explorer. Okay?
Yes, sir.
Have you heard of a name Berzelius?
No, sir.
No? Berzelius, I'm not very much sure about this whole event, about the names at least, but I know the event. Berzelius was perhaps a scientist, I guess in Italy. Almost 80 to 90 years back. Berzelius gave a theory to the world. He said that organic compounds can be created only in nature, not in laboratory. Organic compounds, you know organic compounds? Those compounds which have carbon, like carbon dioxide is a gaseous substance, that is organic substance. So anything that has carbon in it, carbon dioxide has carbon, CO2, C for
Yes.
carbon. So CO2 is a carbonic or organic substance. So he said any organic substance can be created only in nature, only by nature, not by human, not in laboratory. And you know, you'll be surprised to know that this theory was followed by the whole world for approximately 20 to 25 years. Amazing. And one of his students after approx 20 to 25 years created an organic compound in the laboratory. His own student, no one else, his own student created organic compound inside laboratory, and that compound was urea. In these days we use urea as fertilizer in the farmlands, crop production. Isn't that surprising? So it was possible because his student was an explorer. He couldn't be satisfied just with the content his teacher gave him. So don't be satisfied with just what I give you. I'm just an introducer. I'm introducing you with all these things. Don't be just satisfied with that. Be an explorer. Try to find many other things, other possibilities. Maybe you will get some new way to do something. This is possible. Believe it. Okay. So we have learned how to change non-terminating and repeating decimals into P by Q form. Is that comfortable for you?
Yes, sir.
Now the third type of decimal. Case 3. Non-terminating, non-repeating decimals. And you will be surprised to know that no one in the world can change it into P by Q form. It is non-transferable, non-convertible. No one can convert it into P by Q form. It cannot be changed into P by Q form. I told you this is non-terminating, non-repeating numbers, decimals are actually irrational numbers. And irrational numbers cannot be expressed in the P by Q form, right?
Yes, sir.
These are irrational numbers. So cannot be changed into P by Q form. Done. Now I'm going to teach you about the shortcut for this conversion. Shortcut. Now you might be thinking, sir, why shortcut? We have this long cut method. Are you thinking?
Yes.
Actually, sometimes a question may be an MCQ, multiple choice question,
Yes.
and you need to answer, you need to choose the correct answer. You don't need to show all these steps. So in case of MCQ, you can perform that shortcut. See, 0.35 and a bar sign over 5. Be focused, don't miss it. This is shortcut, very easy to understand, but if you missed it, it may be difficult. What you need to do, remove decimal, remove bar sign, and write everything else here. What is remaining then? Removing bar sign and decimal, we have 35, right? Subtract the digit which is not having bar sign. How many digits do you see without bar sign?
0 and 3.
0 is not having a value here, so 3. Subtract and divide by what? Count.
99. 9.
Count how many digits have bar sign?
100.
Only one digit.
1.
Only one digit has bar sign. So only 9 should be written here. write as many nines as the number of digits with bar signs. Is that clear?
Yes, sir.
Now see how many digits are there on the right side of decimal without bar sign.
2.
Only one digit.
Without,
Yes.
without.
On the right side of decimal without bar sign. Only one. So put 1 0 here. Done. Done.
So we don't have to subtract them.
Yes. 32 by 90. And then cancellation. 216 ja, 245 ja. You got the answer. Shortcut. One more. Let's take one more. Would you like to try this?
Yes.
When not talking, you should keep the mic off.
Sir, I understand.
If you want to mute, unmute the shortcut button, press the button M. Yeah, quick action. Okay, what did you get for it?
43 upon 99. Sir, but
What
it's
it's
wrong. Sir,
you
I
are
have
right.
also 43 upon 99, but it's wrong.
You are sure that's wrong?
Yes.
I think that's right. Let us check it. (43) divided by 99 equal 0.434343434343. correct answer.
Yes, sir.
Okay, so what we see, what we do, we remove decimal, we remove bar sign, we write the remaining things, that is 43, we subtract those digits, I mean the number made by those digits which are having no bar sign, but there is no digit, so no need to subtract anything, just we can write 0 or leave it. Now the number of digits having bar sign, there are two numbers, put 99, two nines there, and there is no digit without bar sign, so no 0 there, just 43 by 99 answer. So quick and easy if you understand it. Let's try one more. 1.43 bar sign. Try this.
In this question, we can consider 1 as a number.
Yes, you have to consider 1, 4, 3, everything. Done?
So 143 by 100.
You got 143 by 100.
No, sir, I got 7 upon 165.
7 upon 165. Doesn't seem to be correct. Okay, let me repeat the process. I said to remove decimal, remove bar sign, write everything else here. So what should I write for that? What should I write here? Remove decimal, remove bar sign. Your voice is not coming. Check if muted.
So 143.
Correct. 143. And what to subtract?
100 minus 190.
Subtract those digits.
Oh, nothing.
1.
Subtract 1.
Yes. Write all the digits here without bar sign. Write all the digits without bar sign. Only 1 is there without bar sign. So 1.
Yes.
How many digits have bar sign?
2.
2. So 2 times 9. And how many digits after decimal without bar sign?
2.
How many digits after decimal without bar sign? Nothing. Nothing. There is nothing after decimal without bar sign. So no 0 will come here. It's 142 by 99. Done. Answer.
Yes.
Any confusion?
No, sir.
If I write the rule for it, that will be looking very big. However, let me write it in the next page. A is equal to number found after removing decimal and bar sign A is equal to the number that we find after removing decimal and bar sign. B is equal to number formed from the digits without bar sign and C is equal to number of digits wait, it will be very long statement. I am trying to make it compress, that's why I am thinking. Number of nines, number of as many nines as digits with bar. Number of number no, wait. Write as many nines as digits without bar, multiply number of zeros over 1 as many digits on the right side of decimal without bar sign. Very long statement, right?
Yes.
Let me make it more precise. Denominator is equal to write nines equal to number of digits with bar and put zeros equal to digits on the right side of decimal without bar. I think I can't make it more precise than this. So the answer would be a minus b by denominator. A is the first number, that is the number found after removing decimal and bar sign, minus b. B is the second number formed from the digits without bar, and denominator, write nines equal to number of digits with bar and put zeros equal to digits on the right side of decimal without bar. I think it's better to practice with examples only. Let's have
Yes.
one more. Try this one. 5.2 bar.
So 52/9.
Once again. Say again.
51/9.
51 upon 9. Okay.
Sir, 1 second. So 47/9.
47 upon 9. Okay. Just a moment, I am coming. Okay, see. A, number found after removing decimal and bar. What is that number?
52.
52. Minus B, A minus B. So what is B? Number formed from the digits without bar. What is that?
5.
5. And now denominator. Denominator is, write nines equal to number of digits with bar. How many nines?
9. 1.
1 9. And how many zeros over it?
Sir, no.
No zero, right? Sure?
Yes, sir. No, sir, we add 1. No.
Okay, see. Actually, on the right side of decimal without bar sign, on the right side of decimal without bar sign, there is nothing. There is nothing. On the right side of decimal without bar is nothing. So no zero will be there. Okay? Simplify.
47
47 by
by 9.
9. Done? Check it.
Yes, sir. Sir, my answer was
47 by 9. If you divide it, will you get the same?
yes.
Let us check. 47 by 9. 47 divide by 9. Equal sign. 5.222222. So 2 bar. Yes, correct answer.
Yes.
Did you learn it? So let's end the class here only. I hope you have learned all these things I explained in today's class. I hope you have no confusion about them. If you have any confusion, and if you can tell me, else After the class, if you get any question in your mind, just put that question on Telegram. I'll be replying on that.
Okay, sir.
Okay. Bye bye. See you in the next class.
Bye.